from the beginning again. Let us go to the well integrity management system. We'll start here. It is design, constructed, and operation, maintaining, and abandoning. Let us see here design, then drilling, then operating, all the drilling operation, and hand over to the for the workover or completion, completing the well, producing the well, and if there is some problem is being faced, so it is being handed over to the workover for repairing, or then producing the well, then up to the life cycle of the well, then abandon if there is some problem. The next slide here is the definition of the well integrity. Well integrity is application of technical, operational, and organizational solution to reduce the risk of uncontrolled release of formation fluid throughout the life cycle of well. So all the operation actual should be considered and should be organized very well to prevent any leak from the reservoir. Also, in another meaning for definition, it is the concept of well integrity are stages of formation from design, construction, and production which impact well integrity. The financial impact also very high losses of the hydrocarbon that escape damage to the reservoir because of uncontrolled flow. We are going to talk about some of the fluid used while drilling, like the mud. We have to understand what is the mud function. Mud function first, removal of the cutting, cooling and lubricating the bit and the drill string. Also, power transmit of bit nozzle or turbine. Mud assisted in hole prevention, support and stabilization of borehole, containment of formation fluids and gas. Also support the weight of pipe and casing. Serve as a medium of formation logging. Prevent hole wash out due to turbulence, and dissolution must be compatible with drilled formation. Also encountered formation fluid gas. Mud function continue. We are still talking about that. Should not corrode bit, drill string, casing, and surface facility, impair productivity of production horizon, pollute the environment. Should not. Okay. Drilling fluid classification, we have here oil-based mud, water-based mud, pneumatic fluid. Oil-based mud is diesel, mineral, and non-petroleum hydrocarbon. The majority of people now is using non-petroleum hydrocarbon because the first two are considered as a pollution for the environmental. Water-based mud, non-inhibitive, and polymer, pneumatic fluids, dry gas, mist, foam, gasified mud. Also for water-based fluid, non-inhibitive and inhibitive polymer. Non-inhibitive as clear water, native, pneumatic water, and lignite and lignosulfonate. Inhibitive as calcium-based, salt water-based, potassium-based. Polymer, non-dispersed, and high temperature deflactuated. We are going to talk about leak of test. This one of test should be applied after in order to ensure there is a good seal between the casing and it is the first to consider test the first barrier. We are talking about the barrier later now. Anyhow, leak of test is establish a value of fracture gradient to be used a kick tolerance calculation for the next section of the hole to be drilled. It provides the basic data needed for further fracture calculations, and it also tests the effectiveness of the cement job. Leak of test should always be taken to the leak of pressure unless this exceeds the pressure to which the casing was tested. In some instances, such as when drilling development, well, this might not be necessary, and for a formation competency test to be redetermined limit might be all that is required. We are going to talk about the hydraulic. While we drilling, we have to consider a very good hydraulic because we are to clean the cutting from the bottom of the hole to prevent regrinding the cutting. Also clean cutting from the bit and prevent bit walling, carrying cutting up the annulus and out of the hole, cool the bit. The highest penetration means the most important. We have to get the highest penetration rate with the good hydraulic. So we are going to talk about also one point very good. Why production logging BLT? Because it is estimating the flow rate of each phase for each potential perforated interval, and also determining the source of each phase: oil, water, gas. Investigate a cross flow in order to diagnose a production problem such as water production, free gas production. Again here, why production logging for injection well? Estimate the injecting rate to each interval in order to evaluate the water flooding profile, then enhancing the sweeping efficiency. BLT application, evaluating the following well: producing profile, each profile, how much producing from each zone productivity, and estimating also the skin factor for each. Monitoring the change in production profile as how much oil, how much water, how much. This is the PLT logging. We can know how much water producing and how much oil and gas producing from each zone. And accordingly, we have to deal because we have to either to shut off the water or shut off the gas producing. So according to the PLT logging, we are going to decide the decision for shut off. Completion equipment. We have here surface safety equipment, Christmas tree, production tubing and nipples, flow control equipment, including safety valve and tubing plugs, sliding sleeve and shifting tools, bridge plug, and gas lift equipment. As example here for the production, here you can notice this is one of the production string. We have to consider the Makkar, retrievable Makkar as example. This is a considered barrier. We are talking anyhow about the barrier. And here we consider here bridge blood and XL nipple, and so on. So another completion sketch here for dual completion. Dual completion is another one. Here also there is a Makkar here and there is a Makkar here. This Makkar is separating the producing formation from intersecting the other producing zone. Another here completion, and we consider here annulus safety system. Actually, this annulus safety system is the new one, and we consider in order if there is some risk, we can close the annulus and we can make a remedy or jobs or controlling the well. This is very important actually. Another thing here, single string surface production tree. This Christmas tree as in nominated. Dual string also Christmas tree. And here we are talking about well control and barrier. This is also is important thing to understand this one because this is the main target for the well integrity. A primary barrier is defined here as the barrier that initially prevent hydrocarbon from escaping, for example, mud, the tubing, or the Christmas tree. And another point, very important, at least two tested independent barrier between hydrocarbon in the reservoir and the environment at all time. Two at least, not one. Okay, so this is very important to be considered while we are designing the completion string. The secondary barrier is defined as the backup to the primary backing. It is not normally in use until the primary barrier fails. And secondary barrier must be independent of the primary barrier, that is, any event that could destroy the primary barrier should not affect the secondary barrier. As example here, some example, drilling a well. Is the primary barrier here the overbalanced mud, which we nominated it hydrostatic head. And for the secondary barrier is the secondary well head and BOB. Another here running the upper completion. Here also pulling the BOB. When we are pulling the BOB, we have to consider to put a Makkar at deep depth and the tubing. Okay. Another secondary barrier here for the pulling the BOB is the casing head and the tubing hanger. So this is a barrier, some barrier, and it is very important like that. If there is flow coming here, it will face first of all the cement and also the casing should be all seal, very good seal, preventing any leaking. So this is the barrier, and we are going to discuss with very details. Data gathering for the production, we have to get the reservoir parameters and also rock characteristics, fluids and fluids type, exploration and appraiser wells, environment, facilities, drilling, projects, and commercial. Well planning objective. When we are planning the well, we are considering three characteristics: safe, minimum cost, usable oil. Usable oil means should be producing and running even the completion string inside. So this is a usable oil. Safety should be considered a very high priority in well planning. Personal consideration must be placed above all other aspects of plan. The well plan must be designed to minimize the risk of blowout and other factors that could create a problem. Primary cement, as we mentioned, is cement is very important in our well integrity. First, cement isolates zones by restricting flow of movement between formation, support and bond the pipe, protect the casing from corrosive elements such as brine, prevent blowout by forming a quick seal to hold back formation pressure, protect the casing from shock loads during drilling operation, seal off zone of lost circulation. To make or to perform a very good cement primary cementing, you have to consider first of all the clearance between the formation and the casing, the outer side of the casing or outer diameter. So if it is 1.5, the clearance should get more than 80% success in the casing. But if, let us say here, if it is 1 inch, so the success for the casing, it will be reduced, could be 40% or 50%, something like that. Anyhow, you must first of all to consider the annular clearance between casing and the outside of the casing, between formation and outside the casing. And another thing here, we have to consider we call it the centralizer. Centralizer standoff. Standoff, if you have 70% standoff, means less centralizer, casing centralizer, you have very not very bad cementing. But if you have 80% standoff, you have good cement, but 90% you have excellent job. So actually we are going to concentrate in our course for the cement. The primary cement is very important to perform a very good cement from the first moment. We are going to mention that and we are going to clear that, because if you are going to repeat it, you are going to have the problem, probably you don't succeed it. Be repeated by squeezing, I mean. Then another point we are going to talk about is the corrosion control. The conduction of elaborated corrosion surveys on the operation to identify the corrosion problem and recommended and relevant corrosion control program. Preparation of the survey report covering the survey finding and the recommendations, preparing of the cost estimate and the economical feasibility study for the corrosion mitigation program. This is another point. We can know the cement, evaluate the cement, and also know any problem in the casing regarding corrosion, or even if they have a problem like splitting or holes in the casing, we are running this tool is ultrasonic tool. So we can know here the cement bond, it is good or not. And the casing also we can know if there is here something problem for the casing regarding the corrosion or a hole in the casing, we can deal with this one. So this is a very useful tool. Another point here, we are you see here VDL, variation density log. See here also USI and CBL, cement bond log. Accordingly, with a combination of VDL, CBL, we can estimate if there is cement good bond or not, and we have to consider good bond with the casing to the cement, and another consider should be with cement and formation. Both should be are good, and also USI, you can see here, is indicating a very good bond in this interval, but here there is some contamination of between cement and the mud here. Another point here, the US interpretation, cement also can be identified if it is dark, so it is means it is raw cement, means we don't added anything to this cement. If it is little bit light, so you added some additives, and if it is in medium, so it can be very clear with US image. Here, as example, here for rich petroleum test well, here a good cement, this dark one, but this one is contaminated cement. Also this one contaminated cement channeling. Okay, from this data actually we are gathering from USI. Here another point, this is good cement because it is dark. About this one, it is mud cake, and this one is the outer casing reduction. So this is rich petroleum. Good cement also can be, as we mentioned, is from USI, it is dark here, and from CBL, it is good here, and VDL is good. So we have to consider the before perforation, actually the bond between casing and cement formation should be considered. This one should be very good before perforating, otherwise we'll get a lot of problem, and by that way we don't have the well integrity. Another thing here, see this one, this is a channel for the cement, and here is good cement. If you have one like that, actually we have to consider to make a remedy job, which we call it squeeze job, squeeze cementing job. So we can't make a perforation like that, especially if you have two formation zone, so we can't make the perforation. We have to decide very good. You have to isolate it completely between the first zone and the second zone, and also you have to seal off very good. Cement channel and squeeze. Channel and squeeze, here you can see here the this is after squeeze. We have here a lot of channel, and we have here after performing the squeeze, it is little bit improvement, but as I said before, the squeeze cement does not give you 100% success. Should be considered from the primary first cement. Anyhow, cement top here, it is clear. This is also bad because there is here a channel for the cement. All these things should be considered before starting or perforating. Contaminated cement here. This is cement. There is some contamination. For light cement here, also there is some contamination. So we can find exactly a good cement or bad cement from USI or CBL, VDL, so we can judge our casing or our cases. So thank you for, and any question? Okay.